Okay, what we have here, I'm going to put this up out of the way for the moment. Simply a couple of aluminum strips. It's just an aluminum strip there. And that aluminum strip is connected to a segment of aluminum wire. And you can see the shadow back here. This thing's free to oscillate back and forth. Now, really I probably want to smooth out these aluminum strips so that this apparatus hangs pretty freely. And I just realized there's a piece of this apparatus that I can't get to easily. Excuse me for a second here. Actually, I think I can get to it. Okay, sorry for the delay. Now, the idea is we can hook up the generator. Now, I have just two heavy pieces of anything. Doesn't have to be metal, but it doesn't hurt if it is. Sitting on these two strips. So there's a strip here and a strip here. I just want to be careful that these strips don't touch each other, so that the current has to go through this strip, through the metal down here, and back through this strip when I hook the generator up. I hook the generator by simply clamping the two generator leads to the aluminum strips. Then, in order not to have the generator moving around and causing motion in this system, I put something heavy across the generator leads before they run into here. Okay, so you can see I actually put a galvanometer on top of the generator cord. But the leads are attached to the two pieces of aluminum, and I'm careful not to let anything get in between here and here, so that I'm sure the current goes through the loop. Then I can crank, and I can tell by the feel of the crank whether I'm actually getting a current. Now, I will say it might be better to use something that doesn't conduct electricity. I've got two pieces of metal here, but two rocks, anything. The idea here is just to make sure that the only motion that comes out of this is the motion that comes out of the phenomenon that we're going to observe. So now I can crank, and I can get a nice current through here. Now, when I do, the current is going to interact with a magnetic field, and you're going to measure, or you're going to observe at least, how that interaction goes. So you can hold the magnet here, here. Notice that the magnet has no effect on anything. Okay, there's no current moving through here. Now, we can hold the magnet in a variety of orientations: underneath, to the side, near the aluminum strips, this way or this way or this way. Lots of different possible orientations for the ceramic magnet, and you're going to use some of those orientations according to the instructions. Then, after you get an idea what happens, we have these little 2-gram pieces of wood with a couple of pieces of aluminum glued onto it. We can, just from the way these prongs are oriented, I've got two prongs coming out the bottom kind of like this, and I'm going to set that on the wire segment between the two aluminum strips. Then I've got kind of a hook that allows me to kind of slip the aluminum in there. And now I want to adjust this thing so that this aluminum strip is as straight across as possible. Then I'm going to put a magnet here, or here, or here, and see what happens. And you'll see how that works. Now, there's another part to this experiment. I'm not going to actually hook this up, and I'm not going to show you what happens. I want you to discover that for yourself. This is a wire loop. You see that we've got a loop attached here. Now, see how I kind of squeeze down where the aluminum foil meets the wire to make sure that the wire is nice and tight. Now, I just realized that this apparatus is not yet complete. We're going to have a dowel running down the center of this loop. We're going to be able to insert that dowel inside of a straw. So we have a straw that will come up through the dowel and constrain this thing so it can rotate right and left, but not move back and forth or side to side. Okay, so we want to measure the rotational effect of magnetic fields on wire loops. I apologize for the fact that this thing isn't complete, but I must not have given my work-study student those instructions because he's very good and very reliable, and that's certainly my fault, not his. In any case, when we have this thing constrained so that it can rotate but not oscillate back and forth in any direction, we can then take the magnet and hold it in various orientations and see what happens to this wire loop. And there's another thing that we do. There's another piece of wood that's going to come along. We're going to be able to set that piece of wood on this wire loop so that as it rotates, the wood will act as a pointer. However, that part of the instruction is not going to be included on this videotape, unfortunately. Okay, so orientations with respect to the loop: in front of the loop, underneath the loop, to the side of the loop this way, to the side of the loop this way, and so forth. And we'll see some rotational effects, quite pronounced rotational effects actually.